Good day, everyone. Let's look at the first problem I gave you on half-life, decay constant, and nuclear activity. The first question is that an element whose half-life is 3 years has n atoms. How many atoms would have decayed after 9 years? That's the first question, and it is taken from June, let's say June 1992. The second question is that in 90 seconds, the mass of a radioactive element reduces to 1/24th of its original value. You have to determine the half-life of the element. This one was taken from CC, that's GC 1998. Now, the counter rate of an alpha particle source is 400 per minute. If the half-life of the source is 5 days, what will be the count rate per minute after 15 days? Let's see, June 1996. These questions were given to you to solve at first. Now, to solve this kind of question, you need to understand something. First, what is half-life? Half-life is the time taken by radioactive substance to decay to half of its original amount. Time taken by radioactive isotope or element or substance or material to decay to half of its original amount. Now, to solve this question without wasting so much of our time, now let's look at what we're going to do here. We have the first question that an element whose half-life, so you can see that the half-life of the element is given and is what? 3 years, and it has n atoms. So that means originally we have n amount of atoms in the element. Now, how many atoms would have decayed after 9 years? So we are now trying to get the amount that would have decayed, that would have disappeared, that will have left the substance, that will have, okay? We are not looking at the amount remaining, we are looking at the amount that have decayed, okay? After how many years? 9 years. So 9 years is the time. Remember the formula I gave to you? I gave you the formula. Look at it now. I gave you this formula. And this is solution to the first question. You have to give in. I've told you, anytime you have to solve any question in physics, you write out your givens. Now, the given is what? The half-life in the question is what? The first question, 3 years. Now, original amount of atom is what? N. Time taken is what? Is 9 years. And recall the formula I told you. The small n is the amount remaining. The capital N is what? The original amount, which is the parent amount or parent nuclide or parent element. This is like the small n is the daughter element. All about 2 is per k, where k is just a constant, it's not the k constant. And the other one is that t, which is the time taken, is now going to be what? K, which is a constant, this constant times half-life. Now, where after explaining all these things, n is what? Amount remaining, the daughter, the capital N is the original amount, the parent, and the k is just a constant. And t is time spent, and t half is what? Half-life. Now, putting this parameter into this, you'll see from what we have here, it's very easy that we can get k, since we know that we know what t is, which is 9, and we know what t half-life is, which is what? 3. So from there, put t, small t into this, we have 9 equals what? K times t half, which is 3. At the end of the day, k will equals what? 9 divided by 3, and that's going to be what? 3. So k constant, the constant k is what? 3. Now, since we have gotten our, so k is going to be equal to 3 from here. So since we have gotten, so that's what I'm saying, t equals to this. So put this 9 equals to k times 3, k equals what? 9 over 3, and that's going to be 3. So since we have gotten our k to be 3, so what do we do now? Now, we have to get, what are we going to get? We have to get the amount that will be what? Remaining, which is n. That's not the amount that has decayed though, that's the amount remaining. So amount remaining is going to be what? Parent original amount about 2 raised per k, which is 3, and that means n will now be what? N over 2 raised per 3, which is what? 8. Therefore, atoms that will have decayed will now be what? Those ones that will have decayed will be amount, original amount minus what? The amount remaining. Is that not? So the original amount, n minus amount remaining, which is what? N over 8. So n minus n over 8 will be what? 8n minus n all over 8, and that's what? 7n over 8. So that means 7 over 8 of the original amount will have decayed. So that is 7 over 8 of the original amount will have decayed after how many years? 9 years. Is that clear? So I think that is very simple. That's the solution to the first question. Now look at the second question. Now the second question is so easy too. In the second question, we're given a what? The total time taken for the decay to happen is what? 90 seconds. And the original amount was not given. But we're told that what the amount remaining is what? The amount remaining is 1 over 4. You can see in 90 seconds, the mass of the radioactive element reduces to 1 over 4 of its original amount. Okay, the amount of the interval reduces to what this was the original amount. Determine the half-life. Can you see that? So that means the amount remaining is what 1/24 of the original amount, and the time taken for that to happen is what in 90 seconds. We have to determine the half-life of the element. So let's go back. Now we have t equals to 90 seconds and n over 1/24n, which is capital N. So this is the amount remaining now. This is the original amount. So this is the t half-life. We have to call that t equals to what? K times from the formula t equals to kt half, and small n equals to capital N over 2 raised to power k. So therefore, what do we have? We have, since this one is going to be what? 1/24n. So that means this is going to be what? N all over 24. So small n over 24, small n is equals to capital N over 24 equals to what? Equals to n over 2k. So n will cancel n. What do we have? 2 times 1, 2k, 2 raised to power k times 1, 2 raised to power k. 24 times 1, 24. So what do we do in this case? To find k, what do you do? You find the logarithm to be 10 of both sides. Log 10 of both sides. So k can come down from your logarithm rule. Okay, so we have k log 2 equals to what? Log 24. So divide both sides by what? The coefficient of k, which is what? Log 2. So we have 24 over what? Log 2. So press your calculator to get this, and you get your answer to what? 4.6. But we are getting our k now. K is what? 4.6. Now we have to get t half. We have to get t half, not t. T is given to be 90 seconds, so we get t half. But t and t half has a relationship, which is what? T equals to kt. But we know our k now, which is what? What is our k? Our k is 4.6. So, and we know our t half. What's our t half? We don't know. But we know our t. What's our t? 90. So we can get our t half. So t half from here will now be what? K t from here. This means that what? T half plus what? K over what? T, sorry, over k. Okay, so t half is what? T over k. What is t? 90 seconds over what? K, which is the constant, 4.6, and the answer gives you what? 19.6, which is approximately 20 seconds. So that's the solution to the second question. Now let's look at the third question. The third question is that the count rate of alpha particle source is what? 400 per minute. If the half-life of the source is 5 days, the half-life is what? 5 days. The half-life is what? 5 days. Now, what would be the count rate per minute after 15 days? Count rate of alpha particle source is this, which is what? 400 per minute. That is the parent count rate. So that means the parent count is what? 400. Now, the half-life of that parent now is now what? 5 days. Now, what will be the count rate per minute after 15 days? Now, that means what is now going to be the amount remaining after 15 days. So we are calculating what? N, small n. Very good. So let's look at it. Now, to solve this, the capital N, which is what? The original amount, or the parent nuclei is what? Or parent count rate is 400 per minute. Or 400 count per minute. The half-life is 5 days. The N we don't know. At how many days? At 15 days. So T will now be what? After 15 days. So T will be what? Small t is K T half. So you can get a K here. So what's going to K? K is what? Small t over T half. Small t is what? 15 days over T half, which is what? 15 over 5. And that gives you what? That gives you 3. Now, so that the amount remaining, which is what? N, small capital N over 2K. So, you know, we have gotten our K from here, which is 3. So capital N is what? 400. And 2 is what? 2 is raised to power K, which is 3. So 400 over what? 2 is power 3, which is 8. With 400 divided by 8, and that's 50. So we have 50 count per minute to be the what? To be the amount remaining after how many days? 15 days. Thank you.